Let's take a look at the question. It says, let theta be any angle in standard position whose terminal side contains the point -5 and 3. Find three trig functions. We'll assume the three trig functions are sine, cosine, and tangent. First thing, let's plot our point. That'll be 1, 2, 3, 4, 5, and then up 1, 2, 3. And so we'll have an angle whose terminal side goes through that point. We can make a triangle out of this. It's called a reference angle. It's the angle that's made between the terminal side and the x-axis. And we know that it goes vertically in the y direction, 3. It goes to the left, -5. What we need to find out is the hypotenuse. And since it makes a right triangle, we can use the Pythagorean theorem. A squared plus b squared equals c squared. And so we'll have -5 squared plus 3 squared. It doesn't matter which one you let be A or B. And so that gives us 25 plus 9 equals c squared, which gives us 34 equals c squared. Some people forget to take the square root of both sides when they get to this point. Make sure you do. And so the hypotenuse of this triangle is the square root of 34. Alright, the next we want to find the sine of theta. The sine is always the opposite over hypotenuse, so the opposite would be the 3, and the square root of 34 would be the hypotenuse. We can't leave our answer like this. We need to do what's called rationalizing the denominator. We'll multiply the top and the bottom of this fraction by the square root of 34. And so on top we'll end up with 3 square root of 34. Anytime you multiply the square root times itself, you're going to get what's underneath that radical. One thing now you have to ask yourself, can I simplify the 3 and the 34? And the answer is no. Some students want to know, why can't I simplify the 34 and the 34? And the answer to that is the 34 on top is not really 34, it's the square root of 34, which is a totally different number. You find each one of your trig functions by doing the same thing.